Let's talk about the exciting concept of big data. What makes it different from traditional data? We will describe big data's various aspects and some common terms used when dealing with big data. As discussed in the previous video, traditional data is stored in structures with defined formats and specifications. This data is easily collected and can lend itself to common analytical processes. The growth of the internet and the massive flow of digital information between devices created the need to capture and analyze a much larger collection of data for insights, thus big data. There are three main aspects that differentiate big data from traditional data and make it more difficult to collect and analyze. The first is volume. The billions of internet devices create an astonishing amount of data. In healthcare, millions of medical imaging scans and large-scale genome data are examples. Continuously transmitting devices, such as electrocardiograms or ECGs, create great complexity and costs in collecting data. This takes us to the next concept in describing big data. This is velocity, or the rate that data is created. So imagine tracking clicks from all users on a website or calls into a call center. Our ECG example in big data refers to continuously transmitted data, also called streaming data. Data latency, or the time to actually write data to storage, is an important concept in data. But it is especially critical in streaming data, since there is risk in missing important data. Various modern technologies, like Apache Spark, address data latency. The third major item that makes big data different from traditional data is variety. Big data elements can be structured data, like we have talked about previously, or they can be unstructured data, such as textual statements and EHR case notes, pictures of medical scans, digitized audio recordings, or videos. Big data's ability to receive and store this variety of data adds challenges over structured data, but it also enables powerful healthcare analytics, which we'll discuss later in this course. As big data matures, other aspects are being added to its definition. Yet, volume, velocity, and variety are at its core and fundamental to our discussions in this course. With an understanding of what big data is, let's discuss how big data systems deal with data in a novel but sophisticated manner. Google BigQuery and Hadoop are key environments for big data. These environments are distributed computing environments. Distributed computing enables data volume and data velocity by efficiently splitting data tasks into smaller, organized pieces across several or hundreds or thousands of computers. Distributed computing can occur on-premise at an organization or in the cloud. Cloud computing is a type of distributed computing providing enormous data access and scalability. IBM's Watson Health enables tremendous healthcare resources via its cloud platform. To handle data variety, big data systems like Hadoop efficiently situate data as individual files on a distributed computing environment. Specially written computer programs perform steps to access these files and return data. MapReduce is a prominent programming technique that maps a task for the computers to do, then reduces the results into a final result. For example, searching millions of EHR files for the word diabetes and returning a final count. Other systems now exist that let users program in structured query language, SQL, to interact with big data. SQL's powerful yet simplistic approach makes working with big data possible to more data analysts. Although companies are making it easier to work with big data, analyzing big data is still very difficult. Expert skills in statistics and computer programming are necessary. Health informaticists or data scientists usually fill these roles. Later in the course, we will learn about how those skills and big data are generating innovation in the healthcare industry.